Bismillah ar-Rahman ar-Rahim. Combinatorial chemistry. Several approaches have been approved for drug design. The first one is a classical approach. By this step, we make a change on existing compound or synthesize a new structure and see what happens. So in this type of approach, we will synthesize only few milligrams per each compound, and the result will be a handful of compound per week. After synthesis of this compound will be tested. After that, the result will return back to the medicinal chemist, which is responsible for adjustment and refining of structure to obtain a maximum effect with little side effect, to improve activity. In other words, by using this iterative process, a chemist would be able to synthesize only a handful of compound per week. If using this iterative process, a chemist would be able to synthesize only a handful of structures per week. And since the yield of marketable drugs from compound synthesis in a rate 1 per each 10,000 compounds, so this road will success take long time, about 12 years, and the costing may more than $800 million per drug. The second approach, combinatorial chemistry, which is developed in the mid-1980s and make a change dramatically with the introduction of combinatorial chemistry. In this type of approach, the drug discovery process became a highly parallel one, in which hundreds or even thousands of compounds will be synthesized at each one time, unlike the classical one, which one compound per time. In this type, hundreds or even thousands of structures could be synthesized at one time. And interestingly, we have a biologist have a technique called high throughput screening, in which using a laboratory robots for biological testing. We have a plate 8 by 12, 96 well micro titer plate, and application and testing of at least 96 compound per each time. Okay. So the combinatorial chemistry can be defined parallel generation of all possible combination or substituent of or component in a synthetic experiment. Repeat, synthesis of all possible combination of substituent or component in a synthetic experiment. Unlike the yield from the classical one, which only one compound per each time, in this type, the yield from combinatorial chemistry synthesis a chemical library. As we say, hundreds or even thousands of compounds could be synthesized per each time. We have two types of chemical library: either generic library, in which you have a single parent compound and multiple substituents, or mixture library containing a variety of structure type. The total number of structure in library, the final result of this type of combinatorial, will be equal to the product of the various number of substituents in case of generic library. The total number of substituents, while the total number of structure in a mixture is a yield of a mixture library. To understand, we look to this figure. In this type of figure, in this compound, in generic type, we have a single parent compound and various variables, R1, R2, R3, and R4. And each variable have different substituent. Maybe hydrogen or hydroxyl, halogen, carboxyl group, and so on. As we see, we not fix the attachment of R to the aromatic ring. This means maybe ortho, meta, or even para. In this type, the yield, as are two types in this example, and R2 also two substituent, R3 and 4 and 5 substituent, the total number of yield in this example equal to 80. 80 compound pair each time. The second, while the second, which is a mixture, depend on number of different substituent. Okay? If we have no question complete, the medicinal chemist, the rule of medicinal chemist, الصيدلي الكيميائي, تعريف medicinal chemistry is able to design and synthesis of a new compound. Design and synthesis of a new compound. So the medicinal chemist should be able to choose a proper substituent. The type of different substituent should be selected according to the physicochemical property, not randomly. So it will depend on lipophilicity, in which different substituents have different lipophilicity, according to the steric bulk, steric hindrance, and third, according to the induction and resonance effect. So the medicinal chemist should be able to choose a suitable substituent by varying these physicochemical properties. This type of approach, combinatorial chemistry approach for drug design, is a rational one because it depends on understanding. I mean, the medicinal chemist should be understanding the target receptors and the lead molecule. أنا لكي أعمل non-steroidal anti-inflammatory drugs, I should have a good idea about the target receptor. التارجت مالتنا بالنون ستيرويد انتي انفلاماتوري هو cyclooxygenase enzyme. So I should have a suitable and a good information about this type of enzyme structure, and also to the lead molecule. In every type of drugs, there is a lead molecule, which is a parent molecule developed for medicinal use in this type of disease. In case of non-steroidal, the prototype may be regarded as acetylsalicylic acid. By using combinatorial chemistry, we can refining the structure of this non-steroidal lead molecule and found or develop a new compound with little side effect with high efficiency. Another example is dihydrofolate reductase inhibitor. The prototype is the methotrexate. Methotrexate drug is well known as a lead compound for dihydrofolate reductase. This compound, methotrexate, as a prototype, have used to synthesize and test new inhibitors as a model for synthesis of a new compound with better activity. Any question? Third type of approach in drug design before that, what is the goal of combinatorial chemistry? The goal of combinatorial chemistry is to synthesize, purify, chemical analyze, and finally biological test. If we stop at this point, the same goals of a classical one, which is also synthesize, purify, chemical analyze, and biological test. The difference in combinatorial chemistry, you will using as few synthetic experiments as possible. This difference from the classical type. How can synthesize and testing large number of compound chemical library in a few synthetic experiment steps. Finally, computer-aided drug design. A drug design increasingly is based on modern computational chemical technique. We have a database about the disease mechanism, about the receptor properties, and according to this, we will design a new series of compounds, and by computerized chemical technique will predict the biological activity. This type of approach will depend on use a sophisticated knowledge of disease mechanism in which our drug will be act, and also have a good idea about receptor properties. These three types of approach in drug design. Any question? What about the approach in Iraq? Do you expect? Classical. بعد. Sure, it is a classical type, but really it depends on most of medicinal chemists depend on the synthesis of a new compound about study the structure activity relationship of the prototype compounds and make a modification on existing compound. Modification of existing compound by refining of structure. والدليل انه احنا ليس اعتباطيا تماما رغم انه كلاسيكال، انه النشر مالتنا ينشر في مجلات اوروبيه رصينه عالميه ذات معامل تاثير كبير ومجلات امريكيه وعربيه اخرى. اوكي. First, combinatorial chemistry developed or applied to the synthesis of peptides. A convenient method for automated synthesis of these compounds was developed by Merrifield scientists in 1963, in which Merrifield introduced the efficient synthesis of peptides on a solid support or resin as shown in this figure. Before we start to show this figure, we must take a background about peptide synthesis. Okay. Amino acids, as we know, contain amino acid contain two terminal, one carboxyl group and the second amino group. If we react with another one, if we suppose that R1 equal to H, hydrogen, so it is a glycine amino acid, react with another amino acid like alanine if we are to equal to CH3. What are the types of dipeptide may be synthesized or produced? Do you have any idea? Yeah? Amide linkage, yes, but what types of dipeptide? How many dipeptides can be introduced or produced? One. Another? In first case, react of this amino group of glycine of R1 or first amino acid in good with the second one will produce the following compound. No, sorry, NH. CHR, NH, CO, CHR2, NH2. If we suppose R1 equal to H, which means glycine amino acid, R2 equal to CH3 alanine, this type of dipeptide will equal to glycine alanine. But we have another properties, alanine and glycine. So we cannot confirm the dipeptide in this type. And if we add another mono amino acids to this dipeptide, there is high possibility of higher product, different type of a product. In order to introduce our synthesis of dipeptide, as I need one terminal of carboxyl group should be protected. And for second one, a protection of amino group. By this type, I have only one dipeptide will be synthesized, glycine alanine. Before protection, what have? This type, this amine can be react with another glycine with carboxyl and give dipeptide of glycine. And this can react amino group with carboxyl group of glycine of alanine and give alanine. But if we protect amino group for one amino acid and carboxyl for second, only a glycine alanine will be produced. If we want to elongate this dipeptide to tripeptide, if we elongated from alanine, the product of this reaction will be dipeptide fully protected. called dipeptide fully protected. I want to elongate this dipeptide to tripeptide. If from this side I will remove the protection of amine, okay, and should be reacted with this type of amino acid in which free carboxyl group. It will produce a tripeptide with fully protected. If you elongate it from another side, removal of carboxyl protection and reaction of amino acid protected from carboxyl in order to force the reaction as I need. This is basic of peptide synthesis. Any question? In order to return to our scheme. Okay. Return back to our figure. Mirror field. Take one amino acid, protect carboxyl terminal group by small polymer B support, and added another amino acid since carboxyl protected, so we need amino acid protected from amine, using butyl oxycarbonyl as amino protecting group. So in this case, we elongated the peptide from the amino terminal site only. Okay? Protected carboxyl group react with the protected amino group in the presence of DCC, dicyclohexyl carbodiimide coupling agent, produce dipeptide fully protected. Then after that, in second is removal of amino protection group by trifluoroacetic acid in the presence of triethylamine. Trifluoroacetic acid and triethylamine. This will produce a dipeptide protected from carboxyl by small b support and free from amine. And repeat, which meaning by repeat, addition of a protected amine in the presence of DCC result in a tripeptide fully protected, removal of amino side protection result in a tripeptide amine free, and repeat so on until it reach to the specific number I needed. Automated process. This high develop in chemical synthesis in the peptide especially. Any question? coupling agent تساعد على تسريع التفاعل واعطاء اكبر يلد وبها فوائد اخرى. هاي بي او سي بيوتيل اوكسي كربونيل high functional group for protection of amine make it unreactive block. لهنا وصلت للعدد النمبر اللي تريده، هاي اللي حيصير نمبر معين اللي تريده. اخر خطوه اللي حيسوي removal of amine removal of beads يطلع لك البيبتايد اللي تريده انت عاد sequence of amino acid والنمبر اللي تريده. شو وقت؟ اذا انا اوقف التفاعل هنا وصلت العدد ولا اوقف؟ بس لما استخدمت السي اف سي او ايه شلت المجموعه مال البروتين ممكن راح يدخل هنا التفاعل ما راح لا ماكو شيء كله تحت السيطره انت بس هذا مو ثواني، هذا ياخذ له وقت الى ان يصير السرنج ويصير الكسر للامين بروتكشن. نعم بروتكشن هو البيوتيل اوكسي كربونيل. اول بحاله الميرفيلد هسه راح ناخذه بالمحاضرات القادمه سمول بيد سبورت، صح البوليمر بيد. رح ناخذ صفاته، ناخذ انواعها. بعض البيد مو سوليد سبورت، رح تكون سوليبل بوليمر، يعني صار عليها تطور كثير فيما بعد. هاي اول ما بدا عام 1963. الكي فيتشر المهم اللي سوى لنا اياه rapid and automated synthesis of peptide by using a key feature شنو؟ attachment of growing peptide chain on inert polymer bead. يعني مسكنا اياه من جهه وطوينا من جهه اخرى. واوتوميتد يعني يضيف بروتكتد امينو اسيد، يطلع لنا الداي بيبتايد او السيكونس الطالع، ريموفال اوف بروتكشن، اديشن ريموفال، اديشن ريموفال، راح يصير مثل الختم الى ان يوصل للعدد اللي هو يريده. سؤال؟ any question؟ البيتس اللي قلنا inert polymer بها خواص. can be immersed in solvents, different solvent, washed, heated without any inert, without any reaction. After complete the synthesis, the beads can be separated by suitable condition and filtered from the solution, and the final product will be cleaved, yielding pure product, pure final product. Any question? سؤال شيء نكمل؟ جاء بعده عالم هنغاري طور فكرة الميريفيوس سينثيسيس، وهذا العالم الهنغاري أرباد فوركا هو يعتبر مخترع أو أول من وضع بحث أو الخطوة الأولى في الكومبيناتوريال كيمستري. أرباد extended the synthesis of all possible combination of a given set of amino acid a limited number of steps. Unlike Merrifield, we choose the same amino acid. Arbed say it is possible to use a combination of a given set of amino acid, maybe use different type of amino acid and synthesis of a peptide in a limited number of steps by the technique called splitting and remixing portion of the peptide bond resin at each step. Mixing and splitting. ويعتبر هذا العالم أول، مثل ما تكلمنا، أول من وضع اللبنة الأولى في الكومبيناتوريال كيمستري. The first literature reference to a combinatorial chemistry experiment. Return back to our figure by this type of figure. Hungarian chemist take 3 containers container containing amino acid A, container containing amino acid B, container containing amino acid C. Okay? Make a protection by solid support bead to the amino acid A and protect amino acid B and protection of amino acid C. One of the most important one. إذا هذه الخطوة ما سويته رح يصير ترى الشغل المفروض بقية غلط، لأن قلنا الاحتمالات رح تصير عالية. أوكي؟ ما شلون كمل العالم؟ إجا سوى لهن ميكسينج in one container This container will contain a protected A, protected B, protected C, then separated, then added to 3 containers. Each container will be contain protected A, protected B, protected C. Protected A, protected B, protected C. Protected A, protected B, protected C. Repeat. Amino acid protected, amino acid protected A, protected B, protected C. Mixing together in 1 container, separated in 3 containers. So each container will not contain only A. Mixing. Contain A, B, and C. Then after separated, we will add in the first container only A amino acid. In the second only B amino acid. When the third only C amino acid. In this case we have a 3 mixture, a 3 container, each one contain a 3 dipeptide. A 3 mixture, each mixture contain a 3 dipeptide. Mixing again in 1 container and splitting. Splitting ده حنكمل على الجهة الأخرى. فوية إذا حتى لو بحس ناصي. Container in order to avoid the repeating of the same tripeptide, written like me. Container A, protected A, protected B, protected C. Added A. Container ثاني protected A, protected B, protected C. Added B. Protected A, protected B, protected C. C. After separation, we will add only amino acid A. In this container contain 9 tripeptide in this container. 9 tripeptide. The second container also started protected A, protected B, protected C. Added B. Protected, or in order to make the same sequence, I prefer to like this starting A, protected A, protected B, protected C, B, protected A, protected B, protected C, C. Second container should be add only B. As we see, we will have second container contain 9 tripeptide. There is no identification of any 2 tripeptide in each container. Also the third one like this. Container A, container B, container C. Okay? Protected A. We will add A. Third fish نضاف C. Container A, protected A, B, C. الاديشن B. protected A, protected B, protected C, 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 C. In this case, we will have 27 tripeptide, not identical, not repeated, in a few steps, not in 27 steps. If we return, take a protection of one amino acid, protection, mix together, the container will contain 3 mono peptide, mono amino acid, separated in different container. Each container will contain a protected amino acid of different type, A, B, C. In first line, we add only amino acid A, the second only B, and third only C. Mixing again, splitting, and complete. Any question? Any question? The difficult one, how can I identify the biological active one? If we suppose this BCB tripeptide is the active one, how can one separate or identify this tripeptide from 27 tripeptide? This is classical type. If we taken 27 biological tests, it is large number. الcombinatorial chemistry قلنا in a few steps as possible. هذا ما يطلق عليه deconvolution. Before start with deconvolution, if we take the advantage of split and mixed synthesis, all 27 tripeptide can be synthesized in just 3 steps, mixing and separating, 3 steps instead of 27 steps. Disadvantage, the final product is not a pure product. It is a protected final product. So should be removal of a protection in order to obtain a pure compounds themselves. If activity is detected in one of the mixture, again, we have 3 container, 3 mixture. Mixture 1 contain 9 tripeptide, second 9 tripeptide, third 9 tripeptide. We will test the mixture as a whole. This is a simplified process. The really process is very complicated one. So we will test the 3 tests. Each mixture tested. So if I identify in question that BCB is the active one, you should be written that we will test 3 mixture component. Then the first one will not have activity and the third one will not have activity. Only the second mixture will contain the activity. Okay? Understand me? Okay. So this removal and this removal. This type is a second mixture, which mainly from the B amino acid. Return back to 1 step only. 1 step only to this. We look back to protected A, B, C, A, B, 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 C, C, C. This type of this without the third amino acid. This mixture of 9 tripeptide, really, it is a mixture, 3 mixture of dipeptide. but the difference is the try is only the B. So we add to this step only the B. And again tested the compound. Tested each mixture separated. Where is the one? BCB. Okay. Put the star on it. Then after that, test is separated. The first mixture not have activity. The second also not have activity. The third one will have activity. Return to the first step. Separated A, B, C. Coming off from the second step, which only the B. نضيف للجميع B, B, B. Since it is observed only in the third line, we add only C. No, sorry. نضيف sorry. BCB is the active one. Return to first step A, B, C. Added, since it is the third one, we add only C. Since the final tripeptide comes from the second one, only B will be added and then tested. So it will observe that BCB is the active one. Slightly difficult. Repeat in another example to be. In my question, I will identify the active one. Suggest one active of from these 927 CBC. C لا احنا شو اخذنا هسه ها CBC. I prefer to discuss with me the step, to complete the steps with me. After finishing the 27 tripeptide in 3 mixture, tested 3 mixture separated. Okay? CBC is the active one as identified in the question. Okay? So the first and second line will be removed. Okay? The third one, deconvolution, return back step by step. So we'll return to the second step, the step before this, which contain a 3 mixture of dipeptide. Okay? Since the CBC is identified in the third one, which means the addition is only C. C, 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 C. Then, what will go to do? Should be right. We will test the 3 mixtures separately. Okay? What is CBC? Okay? And then when tested 3 mixtures separated, the first and the third one will be excluded. The second one will be taken. If it is like this simplicity, one may say separated the three compound and tested separately, three tests only. But it is more complicated one. As a general rule, should be returned to the first step. And since it's come from the second container, we should add B. And the final one, observe in the third one, we will add C. Biological test for separated three compound. So we have in this case only one compound. CBC is the active one, and this is the less active one. Slightly modified, yes, slightly modified. ممكن راح اعطيكم مثال اخر ابسط على الديكونفوليوشن، شلون نسوي ريتيرن باك ستيب باي ستيب، اسهل من هذا المركب. شلون نسوي identification for active compound from a series of compound. In a classical one, we'll test each compound separately. Long time, costly, okay.
هذا المركب اللي يسوونه احنا مباشره نعرف هسه هذا الاول طلع بالبي وهو بالبي طلع وهذا
لا
هو طلع بالسي مباشره. هاي صدفه.
Please listen to me. When identify in equation the CBC indicated that CBC or any one of tripeptide is the active one. This found in container contain 9 compound, not in this sequence. It is mixed. We cannot know from the beginning is the second line and we reach to it as easy as it. Yes, بس نعم، ولكن أنا أريد الإجابة النموذجية. تشمل سي بي، شلون تفهمنياتها وصلت لها؟ Not by chance. And in this simplified figure, it is okay, can be seen directly. Any question? Sorry, complete the lecture. A process called deconvolution, the synthesis is repeated in iterative manner, producing smaller and sometimes overlapping mixture, as we see in the above example. The screening is repeated until the active compounds are identified. This may be come in exam. The screening is repeated until the active compounds are identified. Not necessarily the last step is the active compound between two brackets. Okay. Deconvolute to make the result of combinatorial experiment less complex, usually by backtracking and reanalyzing or resynthesizing a subset of structure in the library, step by step, as we say. So the goal of deconvolution to determine which of a mixture compounds is actually responsible for activity. After identify the mixture, repeat it step by step to reach the active compound. I will take a table, simplified, outline, show how 4 steps will identify the 3 active components in a 20 compound investigation. If we suppose we have a 20 compounds, assume that the project called the synthesizing of 20 compounds, A to T compounds, rather than carry out 20 distinct steps, 20 synthesis as the classical one. In this case, screening experiment, all of which can take a week. The combinatorial synthesis are carried out as seen in this table. In the classical one, take many weeks, costly, and meaning we have a 20 synthesis compound and a 20 testing. If we discuss this table on the blackboard, we have 20 compounds from A to T compound. A, B, C, D, T. We will separate these 20 compounds in 4 mixture. 20 compounds. Since it is able to divide it by 4 without residual, so the 20 compounds divided in 4 mixtures, so each mixture will contain 5 compounds. So the first mixture contains A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. 20 compounds separated in 4 mixtures. Each mixture contains 5 compounds. If I identify the active compound from the beginning, it is in this example B and H and N. Okay? After separated in 5 component mixture, tested each one separately. So mixture 1, 2, and 3 will be active. The 4th one will be rejected, inactive. In this case, we have 3 mixture. Each mixture contains 5 compounds. So the total number of compounds? 15, yes. 15 compounds, which can be divided by 3 without remaining. So divided in a mixture contains 3 compounds only. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. The active one N, H, B. Okay? We have 5 mixtures. Each mixture contains 3 compounds. Biological test of this mixture. 3 will be observed activity, 2 will be excluded. Excluded this and this. We have mixture of 3 compounds. We can make overlapping to produce two compounds from each. Any 2 compounds from ABC, maybe AB, AC, okay, or AB, BC, the same result will be obtained. GH, suppose HI, MN, NO, الactive one and قلنا H and B. Okay, tested. This mixture not observe activity. This mixture of dicompounds have activity. If the activity is due to a compound, this compound should be active. So it is sure B is the active one. Yes?
BC.
BC, okay. Take BC and AB. AB. أنت تأخذ احتمالين من هاي الثلاث مركبات، احنا نريد فيو ستيبس، لأن أي احتمالين تعطيك نفس النتيجة، فليش نسوي ثلاث احتمالات؟ اختار أي احتمالين، مو شرط الآن مختارين راح يطلع لك نفس النتيجة. خلينا نباوع، هسه اخترت اي بي اي سي، جماعتكم قال بي سي اي بي، هو شنو الفاعل الاكتف؟ البي، بما انه باثنين اذا هو المشترك، اذا بي. هنا ايضا جي اتش اتش اي، اذا الاتش هو المشترك. هنا الان any two compound any two mixture يعني will give you the same result. Only one will be active.